Hey gang, I wanted to do a quick video here, just proving one of these sum and difference identities. I'll do the difference identity for cosine, which is that the cosine of a difference, cosine of alpha minus beta, is equal to cosine alpha cosine beta plus sine alpha sine beta. It's just a neat proof, and it kind of shows you, it's amazing that someone thought of this, but like all good proofs in trigonometry, you start with a picture. And so we need, for alpha and beta, we need a couple of angles. So I'm going to go ahead and draw angle alpha, and I guess color coding this might be the best way. So in green here, I'm just going to arbitrarily pick an angle, right? There it is. That's angle alpha, right there, that's alpha. And I need another angle, I don't know, what do you think, purple? And let's make it a smaller angle here. We'll make this one beta over here. That's angle beta. So from here to here, that measure is beta. And why do I have alpha and beta? Because now between them would be alpha minus beta, right in here. So this angle from here to here, that would be alpha minus beta, right, by subtraction. Okay, so far so good. Now, don't forget, all of trig, we started the year, it's on the unit circle with a radius of 1. So, these angles, these have a side length of 1, right? And from here to here, this is 1. So two sides of our triangle have a length of 1. You know what else would be good? Getting a couple coordinates. Well, for alpha, let me color code this again, right? Hey, what's my x coordinate? Well, that's the cosine. That's what cosine is. It's the x coordinate on the unit circle. So this is cosine of alpha, and the y coordinate is sine of alpha. And for this purple angle, for angle beta, the x coordinate, well, that's just cosine beta, and the y coordinate is sine of beta. Hey, we got Greek letters involved, so already it looks impressive. And tell you what, let's close up our triangle. Right? Let's actually connect these so we really have a triangle. How about that? That's the triangle with an angle of alpha minus beta, right? So, here we go. Let's focus on this triangle right here. I know two of the lengths. The third length I don't know. We'll call it D for distance. I don't know what else to call it. We'll call it D. Let's try to calculate it. So there's two ways to calculate that. We're going to calculate it both ways. I need to give myself a little room, so I'm going to move down here on my page a little bit. By the way, that's just the x-axis and the y-axis in standard position. It's a couple of first quadrant angles. All right, one way, and we just did this, was the law of cosines. Why law of cosines? I'll tell you why. Because we have side, angle, side. We have two sides in the included angle. So let's go ahead and write that out, right? It's the law of cosines. If I have alpha minus beta as my angle, opposite that is side D. So that's how I would start. D squared is what? 1 squared plus 1 squared. Law of cosine starts out like at the Pythagorean theorem, and then minus 2 times 1 cosine of the angle in between, which is alpha minus beta. Yikes, ugly looking. We can probably clean it up a little bit. 1 squared plus 1 squared is 2. 2 times 1 is 2, and I still have cosine of alpha minus beta. All right, so far so good. Could I take a square root? Sure, but let's leave it, for now we'll leave it as D squared. Okay, so that's one way to do it. The other thing I can do is something we haven't talked about in quite some time, but in geometry, you guys have the distance formula that given two coordinates, you can find the distance between them, and it's really the Pythagorean theorem. Do you remember the distance formula? It said distance is equal to, the distance squared is what? You subtract the, you subtract the y coordinates, I think it's like this, right? And subtract the x coordinates. It's a spin-off of the Pythagorean theorem. Like that, right? Okay, well, we can do the same thing to get d here, right? D squared would be what? Subtract the y coordinates. What are the y coordinates? It's the sine values, right? So I could go sine alpha minus sine of beta, square that, and then I could subtract the x coordinates. That's cosine alpha, right? Minus cosine beta, and that gets squared. Okay, who's up for some serious algebra? Okay, I can see all your hands are up. Great. So we're going to square each of these. So let's focus. Hey, let's focus on this one first. If we square that, right, you got to square the first term. That's sine squared. You got to double the products. You got to multiply them together and double it up. So that's 2 sine alpha sine beta. Again, I'm just squaring that binomial. And then you got to square sine beta, which becomes a positive. Okay, that's all. Hey, let's color code it. That's all in red. That's what I did there. I squared that binomial. All right, I'm color coding because this is a lot. And then I got to add this part. What do you like, green? Let's do this part in green. Right, and I got to be. I'm going to do it right below. So I got a cosine squared. I got to square that cosine, right? So I got cosine squared alpha, right? I got to double it up in the middle. Minus 2 cosine alpha cosine beta, right? And then I got to square the end, so I got cosine squared beta. Let's put that all in green. Maybe I'm throwing too many colors into this, but that's a big equation. In fact, you know what I should do? Clean this up as best I can. So here we go. D squared. I guess I just got to write smaller, right? And I'm going to reorder it. I got sine squared alpha, and I got cosine squared alpha. So I'm going to group those together, right? And then I got sine squared beta and cosine squared beta. I'll group those together. I think some of you probably see why I'm doing that right now, right? And then in the middle, I got all of this junk, right? With a common factor of minus 2. So how would I factor out minus 2? And then I got sine alpha, sine beta. If I factor out a minus 2, I actually get a plus cosine alpha, cosine beta. And we're already starting to look a little bit like that. That should look familiar from the cosine difference formula. Now we can group some stuff together, particularly these guys, right? I got that sine squared alpha plus cosine squared alpha. Hey guys, that's equal to 1, right? Sine squared beta and cosine squared beta, another 1, right? I can bring down the rest, this minus 2, all that. I can copy all that business, bring it down, paste it. Oops. All right. And, you know, obviously 1 plus 1 is 2. I feel like I'm doing a lot of copying. You can see it's a long proof. And I got to bring all this down. I guess I'll recopy it. Sine alpha, sine beta, cosine alpha, cosine beta. Right? Okay, so now here's what I got. I got 2 formulas. Maybe this time I'll star them. From the law of cosines, I got that guy. From the distance formula, I got this guy. They're both equal to d squared, right? And if I got 2 things equal to each other, I can use the transitive property to set the other side of the equation equal. So I'm going to bring all that down. I got 2 minus 2 cosine alpha minus beta equals all of this. I'm going to cheat again and use the Apple Pen to copy that down. And I'm going to, oh no, I'm going to paste it right over here. There we go. Try to make it just a little bit bigger. Okay. And then I think you see what's going to happen. We're going to cancel a lot of stuff out, right? I can subtract 2 on both sides. That knocks those guys out. And I could divide by 2 on both sides. So if I divide by negative 2, those guys knock out. And look what's left. I'm left here with cosine of alpha minus beta, and here I'm left with sine alpha sine beta plus cosine alpha cosine beta. Now, whoever thought of this, man, pure genius, right? And you could see not the easiest proof in the world, but that's what was to be demonstrated. So I'll write QED. All right, guys, I hope that helps. And for what it's worth, all the other formulas are spin-offs of this one. This is the hardest proof there is, but that's the proof of the difference identity for cosine. So I hope you found that interesting.